Welcome to an Achieving Science video. This video is going to go through Newton's second law of motion. So Newton's second law states that a resultant force means acceleration. This means that if there is a resultant force, i.e. the forces are unbalanced, there will be movement. Let's show this in a diagram. Here we have a car and we can label the two forces, one backwards and one forward force. If we add values to this, we can have 500 newtons acting backwards and 750 acting forwards, where 500 newtons is friction and the 750 is the driving force. From this, we can calculate the resultant force by subtracting 500 from 750 to equal 250 newtons, meaning there is a 250 newton resultant force acting forwards on this vehicle. Now, the larger the resultant force, the more the object will accelerate. Now, force and acceleration are said to be directly proportional. This means, as the force increases, the acceleration will also increase by the same percentage. This can be shown via a graph, where on the x-axis we have force, and on the y-axis we have acceleration. As this is a relationship which is directly proportional, we have a straight diagonal line as shown on the screen. Now, another key relationship is that acceleration is inversely proportional to the mass of the object. This means as mass increases, the acceleration will be smaller. Again, this can be shown by a graph. On this occasion, we have mass on the x-axis and acceleration on the y-axis. This time we have a downwards curve. Using these two relationships, we can therefore come up with an equation. The equation that links these two is that force equals mass times by acceleration. Like all equations, this can also be simplified into letter form, where F equals ma. F stands for force measured in newtons, m stands for mass measured in kilograms, a stands for acceleration measured in meters per second squared. Let's use this equation then to solve a question. A car with a mass of 1,500 kilograms has a driving force of 4,500 newtons and a drag force of 4,300 newtons at 60 miles per hour. What is the acceleration at this speed? Well, use the equation, input the values that you know. First of all, resultant force, you have to subtract the two together to work out 200 newtons. The mass is 1,500. And then rearrange the equation using the triangle. Therefore, F divided by m equals a, so that's 200 divided by 1,500 equals 0.13 meters per second squared is the acceleration.